Chapter 9, Matrices or Matrix, the singular form. So chapter 8 is about matrices. Let's start with this picture. Of course, want to just tell students today we are going to learn about matrix. The first thing that it comes to their mind is, what is it? Maybe the movie, right? That's your expectation. But in reality now we're going to talk about something like in this picture. As you see here we have a B, and here we have a rectangular brackets. Inside we have numbers, right? In rows or in columns. A similar thing here, right? And also here the similar thing, that is E equals something. And also we have another matrix. Okay. So that is what we are going to learn in this chapter. We are not going to learn everything about matrix, but very simple operations on matrix. What is a matrix and how do we add them? How do we subtract them? How do you multiply a matrix by a scalar or real number? How do you multiply two matrices together? And after that, problems. I mean, we will learn how to solve some problems that we actually how to say face in our daily life situations. Okay, when you're running small businesses or something like this. So we will just talk about the use of matrices in those applications. So what is a matrix? All right, first, if you answer this question, matrix is simply a rectangular arrangement of numbers in rows and columns. As you see here, we have rectangular bracket, right? Inside we have numbers, but those are arranged numbers, right, in rows and columns. The first thing you have to know. As I say here now, immediately when you just say matrix, you just imagine that or visualize that we have rectangular matrix, and inside that those brackets, we have numbers in rows and in columns, right? And they are arranged in certain order. So the order of a matrix, what is it? It's just the number of the rows and columns. And also, actually, this is very important, but we are not going to talk about this in detail. But when you say order of a matrix, it means that how many rows or how many columns does it have, or rows and columns. For example, in the previous one, the first matrix, it has 2 rows and 2 columns, right? So that is 2 by 2 matrix. In the second one, for example, it has 2 rows and 3 columns. We call this, it's a 2 by 3 matrix. So entries are the numbers in the matrix. Each number in the matrix, we call them entry. Simply, we just call them entry. Okay. Some special matrices. For example, what is the order of this matrix? As you see here, we have 1, 2, 3. It has 2 columns, right? It has 2 columns, 3 columns here. The first column, the second column, third column. And how many rows? It is 1, 2. First, we have to write the number of rows. So this matrix is 2 by 3 matrix, right? Because it has 2 rows and it has 3 columns. I mean, just identifying a matrix. Another one is, how about this one? As you see here, it has 1, 2, 3. It has 3 rows and 1, 2, 3. It has 3 columns. So this is a 3 by 3 matrix. And also, if the number of rows is equal to the number of columns, we call this a square matrix. Because as you see here, it looks like a square, right? That's why also we call this square matrix. Okay. How about this one? Immediately, if you just count the number of rows here, the first row, the second row, and the third row, so it has 3 rows. How about columns? 1, 2, 3, 4, 5. It has 5 columns. So the dimension of this matrix, or the order of this matrix, is 3 by 5. Is it a square matrix? No. Why? Because the number of columns is not equal to the number of rows, right? And also, as you see here, it's just rectangular in shape, but it does not look like a square. So that is 3 by 5 matrix. How about this one? Immediately you can see that this is a square matrix because it has 2 rows and 2 columns, and the dimension or order of this matrix is 2 by 2 matrix, okay, or square matrix. These are all about the order of matrices. Another one here, how about this one? How many rows it has? This is the first row, and that is the second, third, fourth. So it has 4 rows, right? And how about the columns? It has only 1 column. So that one is 4 by 1 matrix. And also, actually, if a matrix has only 1 column, we call it column matrix because it has a single column here, right? And similar to this, it has only 1 row. We call this row matrix. And how about the order of this matrix? It has 1, 2, 3, 4, 4 columns. How about rows? It has only 1 row, right? So this one is 1 by 4 matrix, okay? By 1 by 4 matrix. It's all about the order of matrices. How about addition of matrices? It's also very easy and simple, okay? If now we know what's the matrix and we know how to identify it is order or dimension, the first operation of matrices is addition. If you're given 2 matrices, how do we add them? Number 1 is to add 2 matrices, they must have the same orders or same dimensions, okay? Then to add 2 matrices, just we need to add their corresponding entries. For example, let's say we are given 2 matrices. Do they have the same dimensions? Yes. This one is 3 by 2 matrix. This one is 3 by 2 matrix, right? This one is 3 by 2, and also this one is 3 by 2. So the dimensions of these 2 matrices are same. So that means that now it is possible to add these 2 matrices. To add 2 matrices, just we need to add their corresponding entries. So this corresponds this entry, right? So that is 5 plus negative 2, here we have. Negative 3 plus 1, here we have. Negative 3 plus 3, here we have. And 4 plus 0, here we have. Just we are adding corresponding entries, right? So after that, we get this matrix, and also the resulting matrix has the same dimension with these matrices. So it is 5 plus negative 2, it is 3, right? And 5 plus 1, it is, negative 3 plus 1 is negative 2, and negative 3 plus 3 is equal to 0. 4 plus 0, that is 4. 0 plus 4, here we have 4. Negative 7 plus negative 3, here we have 4. Okay. So that is how we add 2 matrices. Okay. How about subtraction? It's also very similar to addition. To subtract 2 matrices, they must have the same order. We mean the same order, the same dimension. If it is so, we just simply subtract corresponding entries like addition. Assume that we are given these 2 matrices. What is the dimension of this matrix? That is 3 by 3. And how about this one? That's also 3 by 3. Are they same? Yes. That means it's possible to add. So just write equal sign and add or subtract their corresponding entries. 9 minus 4, 9 minus 4. That's equal to 5. Negative 2 minus 7. Negative 2 minus 0. Here we have. 4 minus 7. Here we have. Right. 5 minus 1. Here we have. 8 minus 2. Here we have, right? Just subtract the corresponding entries. So from here, 9 minus 4 is equal to 5. 1 minus negative 2 is equal to 3. 3 minus 3 is equal to 0. 8 minus 2 is equal to 6. Okay? This is how we subtract 2 matrices. Of course, adding or subtracting 2 matrices, they're pretty easy. There's nothing difficult here. Next operation of matrices, multiplication of matrix by a real number. Okay, because multiplying 2 matrices is quite different, and I will focus on this and spend more time on this. But now here you'll just practice how to add 2 matrices, how to subtract 2 matrices, all right, and how to multiply 2 matrices together. So in matrix algebra, a real number is often called a scalar. Okay, scalar or real number, the same thing. So to multiply a matrix by a scalar, you multiply each entry in the matrix by that scalar. Okay, but here again, don't confuse. We are not multiplying two matrices together. We are multiplying a real number, just scalar, by a matrix. For example, here we have 4 times the matrix. So if I just denote this matrix by A, let's say this matrix is capital A, what we are doing here is we are multiplying a scalar by a matrix. Okay. So we are saying that in the definition, to multiply a matrix by a scalar, we need to multiply each entry by this scalar, right? So here we have 4 times -2, and 4 times 0, 4 times 4, 4 times -1, and 4 times -2, here we have -8. 4 times 0, here we have 0. 4 times 4, 16, 4 times -1, it is -4, right? Because why is this so? Here we have 4 times A. By definition, what does it mean? It means that is A plus A plus A plus A, right? That means that here we have just this, the same thing. What is it? -2 plus -2 plus -2 plus -2. Simple. It's just 4 times -2, right? This is how we define multiplication. Okay. And that's why to multiply a matrix by a scalar, just you need to multiply each entry by that scalar. All right. So, and also a bit later, I will show you how to do these operations on Excel. Some of you might know this, but I'm sure that also there are some students who never practice this. Okay. All right. Multiplication of matrices. Guys, here I'm just introducing you, all right? On each topic, actually, we will study or solve problems one by one. This is just an introduction part, all right? And after that, from each exercise, I will show you some examples, and this is how we study this chapter. So the product of matrix dimensions are, what is it? Rows of first matrix times columns of the second matrix. So you can multiply two matrices if and only if the number of columns in the first matrix, that is a first matrix, that is a second matrix. All right. So in the first matrix equals the number of rows in the second matrix. So if the number of columns in the first matrix, here we have columns 1, 2, 3, 4. And if it is equal to the rows of the second matrix, how many rows we have? 1, 2, 3, 4. So if these two things are equal, then we say that it is possible to multiply. Okay, just first we have to determine, is it possible to multiply these two, the given two matrices or not? First, you have to check this. Okay, if it is so, then we can multiply this. And here, this one is, which row is it? It is third row, right? This one is third row, right? And how about this one? This one is fourth column. So I'm multiplying third row by fourth column. And if you just multiply this together, we will get a single number. And also I will show you this a bit later. And the single number will be placed here. Where is it? In the position of, I mean, at the intersection of the third row and fourth column. Anyway, this is just a simple introduction. Here, for example, two matrices are given. Is it possible to multiply or not? So this one, as you see here, this matrix is 2 by 4, and this matrix is 3 by 4, right? Now, how many columns does it have? This one is columns, right? And how many rows does the second matrix have? It is 3. When I just draw a rectangle around these two numbers, here we have 4, here we have 3. They are not equal. That means it's not defined. I cannot multiply this matrix by this matrix. Okay, so that's why first when you look at the matrices in the question, you will see that multiply the given two matrices where possible. Sometimes it is not possible, sometimes it is possible. So if it is possible, what is next about this? Again, we'll talk about it a bit later. Okay. So engineers use them to solve systems of differential equations. This is about application of matrices. You may wonder, where do we use matrices? Actually, a lot of, they are used in a lot of branches of science, in business. Statisticians use them to tabulate and manipulate data. Cabins use them to calculate quantum states, and business people use it for organizing data and evaluating their daily revenue and a lot of stuff. Okay, so actually here we'll just talk about the application of matrices that is related to business and related to our daily life situations. Okay. All right, matrices are used to represent real-world data such as the habits or traits of a population of people. And here we have, for example, let's say eye color in class, brown eyes, blue eyes, green eyes, black eyes, right? Male, female. As see here, if I just close this part and this part, if I just put here rectangle bracket, what do you see here? What we see here is a matrix, right? And that is 2 by 4 matrix. Okay. So here we have male, just from this table, I mean, how to convert table into matrix. So here male, 9 male students, they have brown eyes, 3 blue eyes, 2 green eyes, 4 black eyes, and female in a similar way. And also I can just do like this, right? For example, this is class A. In similar way, if you're doing some kind of survey, let's say in a school we have, doing this survey on 4 different classes. That is class A, class B, class C, class D. In class A, you go to the class and we have this table and you fill in this table, asking the P students, okay, 9 people have brown eyes, 3 people have blue eyes, 2 people have green eyes, and 4 people black eyes, right? In a similar way, female to 1145. You go to the second class, class B, you ask the same questions to the students, and also you can fill the data. Maybe male, here we have 5, here we have 6, here we have 2, here we have 1, and female, and also class C and class D. Now you have 4 different tables, right? 4 tables which display what is it? Eye colors of the students, 2 different genders, male and female. Now the question comes. So what is, how many people or how many students in grade, let's say 10, have brown eyes? To answer this question, we have to add those 4 matrices, right? And the first entry gives us the total number of brown eyes. Or another question, how many girls have green eyes? In grade 10. In grade 10, we have 4 different classes. I know this table, and I can display this in matrices. You can just add, right, and display or give the answer. Okay, this many students or this many girls have green eyes. That is one application of using matrices. Manually, we can do this, but as you see now, you will see that when we are doing these operations, all of these operations, addition, subtraction, multiplying a matrix by a real number, or multiplying 2 matrices together, they just follow a fixed rule, okay? And that's why it is possible to write an algorithm, and that's why a lot of softwares, actually, we can just perform these operations using these softwares. Even on internet, if you just write online addition of matrices, you can see a software. Or we have MATLAB, also we have spreadsheets. Actually, all these matrix populations are defined there. Okay. All right, guys, before we continue, first we need to solve some questions. After you have some idea about matrix, then I will show you how to do these things manually and also using Excel. Okay. That's just a short introduction to matrices. All right. Guys, I'll send you another link, okay? Just give me 1 minute.